Welcome PhySci 121. This is our media project assignment. My name is Christopher.
I'm Diana.
And I'm Tim. Muscular dystrophy is a debilitating disease that affects 1 in every 3,000 baby boys. There is currently no cure for this disease. However, there are several promising treatments available. In today's talk, we would like to focus on a treatment option that inserts microdystrophin into DMD patients. To make our explanation easy to understand, we will be using the act of transporting supplies to the International Space Station as an analogy to microdystrophin insertion.
This analogy, the spaceship represents the adeno-associated virus, or the AAV vector. A spaceship has to carry essential resources to the International Space Station, similar to how the AAV vector transports the microdystrophin to muscle cells. Similar to AAV vectors, there are a variety of types of spaceships that can do this job of insertion and delivery of resources, meaning the spaceships, like the AAV vectors, all look a little different in their composition, and some are better than others for this job. Most importantly, the spaceship and AAV vector are similar in the fact that they are both temporary solutions to an ongoing problem. If the spaceship only made one trip to the International Space Station, eventually this will lead to a lack of food and other supplies that may be necessary to maintain the integrity of the ISS and people in it. Similar to how the AAV vector that carries the microdystrophin needs to be replaced every so often in order to provide dystrophin to allow for the protection of the sarcolemma in the skeletal muscle.
Similar to how DMD patients cannot independently generate functional protein, astronauts on the International Space Station cannot grow and process their own foods. In both cases, outside intervention is needed for their survival. DMD patients require injections of healthy dystrophin, while the astronauts demand food supply from Earth. Packaging of food for consumption in space is a very difficult process. Space food not only needs to be nutritious and palatable, but also must be suitable for consumption in a zero-gravity environment. Therefore, space food must be specially engineered to be lightweight, lightly packaged, and require minimal cleanup. This same concept applies to gene therapy. Due to the limited carrying capacity of AAV vectors, the full-length dystrophin protein must be truncated to a mini dystrophin protein that is still functional and later transferred into a human cell.
We hope that you have learned from our short demonstration that microdystrophin insertion is a promising treatment. However, there is still much to learn about how durable this treatment is for the long term, and whether we can find the ideal combination of AAV vector serotype and microdystrophin protein isoform.
Thanks for watching!